Fibonacci sequence. We study the evolution of the number of rabbit couples in a farm. So at year 0, we have newborn rabbits. The year after, they become adult and fertile, and they give birth to newborn, and the adult will remain adult forever. I will denote by x1 the number of newly born couples and by x2 the number of adults. And y is the total number of couples of rabbits. From this, I have to give the state equation describing the evolution of the system. So here, the year number 0. I have a farm like this, big farm. And the year number 0, I have newborn. They are here, inside the farm. The year after, the newborn disappear, and they became adult, like this. I am now in this situation. This adult give birth to newborn, like this, but they remain adult. So it means that the year after, I will be in this situation. So I am now here adult, and I am in this situation. The year after, the adults remain adult, the newborn became adult, so this one become here, this one become here, but this one give birth to this one. This is one why the year after I am in this situation. These two adults will give birth to other newborn, and the previous newborn became adult. So I will have this situation, and now I am here. So if I start to write the state equation for this, if x1 denotes the number of newborn I will have at year k plus 1, this relation, because each couple of adults gave birth to a couple of newborn rabbits. Now the number of adults at year k plus 1 is equal to the number of newborn couple that became adult plus the number of adults that remain adults. And the y of k, the total number of adults, is equal to the sum x1 of k plus x2 of k. So this is the state equation of my system with, for the initialization, x1 of 0 equal to 1, because I have one couple of newborn and no adults at year number 0 due to this. Question number 2, we have to give the recurrence relation satisfied by y of k. So for this, I can guess that I have a second order relation which will link y of k, y of k plus 1, and 1 of k plus 2. So I will write all of them with respect to the state, and the state is x1 of k, x2 of k. Here I will get x1 of k plus x2 of k. For this one I will obtain x1 of k plus 1 plus x2 of k plus 1, but I want all of them with respect to this. But x1 of k plus 1 is equal to this, x2 of k plus 1 is equal to this. This is why I can write here the sum of the two is x1 of k, so this one, plus 2x2 of k, which corresponds to this one and this one. Now for y of k plus 2 I will do the same. I know that it is x1 of k plus 2 plus x2 of k plus 2 due to this, which is equal to, as written previously, x1 of k plus 1 plus 2 x2 of k plus 1 due to this, which is equal, so now x1 of k plus 1 is given here, is x2 of k, and this one also, I can take it here. And it makes me 2x1 of k plus 3x2 of k. Okay, so I will consider these relations. Okay, and if you write in a matrix form, I obtain y of k, y of k plus 1, y of k plus 2 equal to, so here 1 and 1, 1 and 2, 2 and 3 times x1 of k, x2 of k. Now from this equation I can remove these I have three equations, so I can remove two variables, and if I isolate, so if I remove x1 and x2, I conclude that y of k plus 2 minus 1 of k plus 1 minus y of k equal to 0, with the initial condition y of 0 equal y of 1, which is equal to 1, which means that the year number 0 I have one couple of rabbits, and here also the year number 1 I have one couple of rabbits. This corresponds to the Fibonacci sequence. Finally, I had here a system which was described by state equation of the form x of k plus 1 equal a of xk plus buk, y of k equal c of xk plus duk. But in my situation, the matrix A was given, so the matrix B is equal to 0, the matrix D is equal to 0 also, the matrix A was equal to 0, 1, 1, 1, the matrix C was given by 1 and 1. As a consequence, my system is linear. I have different way to represent this, either by a state equation, which gives probably more has more physical meaning than the recurrence equation, where it's difficult to see the signification of y at time k plus 2 with respect to y at time k plus 1 and k, whereas here I have more physical meaning due to the state variable. Moreover, here k, the time, belong to z, so there are integers, whereas classically, most of the time in robotics, t is continuous, belongs to r.